Hello everybody. Have you ever poked a hole in a water bottle and watched the stream shoot out? How fast is the water flying out and why does it land where it does? In today's video, we're going to be breaking this down using physics. We will introduce two main physics topics. Volume flow rate Q, which is measured in units meters cubed over seconds, and we find this by dividing the volume of the fluid that's flowed out over the duration of the time. And then this equation tells us how much water or volume is passed through a surface, like a hole every second. It's measured in cubic meters per second, as mentioned before. Our and our second principle is the relationship between the flow rate and the exit speed. We denote this as Q equals the area times the velocity. The units will be the same as mentioned, cubic meters over seconds. This equation tells us that A, in our example, is going to be the area of the hole, and V is the speed the fluid exits. We will use this equation to rearrange to solve for V. Now let's introduce Torricelli's theorem. How can we predict the speed just by knowing how tall the column is? It's V equals to square root of 2 times GH. To relate this, think of water sliding down higher as and higher you shoot it from, the faster it shoots down the bottom. Now that we have a decent understanding behind the theorem and behind our equations, let's apply to solve our problem. So we'll start by erasing some of this work, or we'll start by creating a new page here. Alright, now we're going to start solving the problem. We're going to start by clearing some of our space out of this title page. So we're going to erase these equations here so that we can start solving our problem. And the reason I want to use this page is because we already have a really great diagram to work with. Alright. Alright, the first question asks us, find the volume, rate, flow, speed in meters squared over seconds. So we're going to find this by using our first equation before, where we have our area of water, which is filling up our beaker cup, divided by the time it takes. So we're going to convert this time into seconds so we can work with it better. So T equals, and then we're going to convert it to seconds, which should be 120 seconds. Now let's find the volume flow rate. So it's going to be Q equals our volume, which filled up the beaker, which is going to be 7.28 times 10 to the negative 4 meters cubed, divided by 120 seconds. Our volume flow rate will be something like 7.28 times 10 to the power of negative 4 divided by 120, which is going to give us 6.6. 0.6 times 10 to the negative 6 power of meters cubed per second. Now the next question asks us, find the speed of the liquid as it exits. We know that we have this height above the liquid, and then we're going to use our flow rate from before to solve the next part. So we're just going to rearrange it. So we know that Q, or the flow rate, equals to the area times the velocity, but if we divide the Q by the A, which is our area of the hole, we can solve for velocity, which is going to be 0.6 times 10 to the negative 6 power meters cubed over seconds, divided by the area, which is going to be, as we can see in the top right, it's going to be 2.5 times 10 to the negative 6 power meters squared. And this will give us our velocity as we calculate this. So 2.5 times 10 to the negative 6 power, which will give us around 2.43 meters per second, which is pretty reasonable. And we're going to circle our solutions as we go. So here's our velocity, and then here's our flow rate we've calculated so far. Now our next question asks us to find the h above our water, the result that gives us these results. So we're going to use Torricelli's theorem that this theorem applies to any like free falling object, but in our example we're using liquid. You can apply this to a ball or whatever. The equation's always the same. So the velocity equals 2gh. And now we're going to rearrange this to solve for our height. So it's going to be v squared over 2g equals h. And now it's just a plug and chug. So we're just going to plug it in. So it's going to be squaring a result from before, divided by 2 times 9.8. And that will give us exactly 0.3004 meters. And that's all the questions we have. That's all the problems we have for today. Now that we have a decent, now that the principle explains everything from, that we just mentioned, explains anything from garden hoses to fountain design, you can practice at home by poking holes in a bottle and observing the stream arc. And thank you for watching my video today. And don't forget to subscribe and like to continue my motivation.